Hello everyone. In this session, let us learn how to calculate time complexity of a recursive algorithm and how to solve the recurrence relation that we will be obtaining in the solving of this recursive algorithm. Before proceeding, one note. So this is a continuation of earlier lecture. If you have not watched it, please watch earlier lecture and then come back. It will be easy for you to follow. So now let us take the recursive algorithm. So this is the algorithm you are already familiar with. We have already used in the computation of space complexity. The same thing I'm using here. Okay. So first let us solve introducing the count variable. Okay. Using the first method we are doing it. So here, where and all I should introduce the count variable. Okay. So I should introduce count variable for this if. Okay. So let me write it as C is equals to C plus 1. And then for the return, I need one more count variable step. I'm writing it for one more time. And here in the else part, I have one more return. So let me write this count variable step one more time here. So now, if you analyze, okay, I'll just show you these steps in a clear way. I have done it in the next slide for you. Yeah. So this is what is happening. If n is less than or equals to 0, okay, so for the if part, I have taken this count. Count is equals to count plus 1. Okay, then for the return. So this return is the body of the if. And here we are introducing one more count statement. And then in the else for this return, we are introducing one more count. So let's see how many times this count variable gets incremented. Okay. So if we see the first if part, and here one more thing I would like to highlight is why I have written this count statement before if. The reason is whenever this if condition becomes true, then we will enter into the body of if. Okay. Though the if condition is false, also this if is getting evaluated and it becomes false. So it comes to the else part. So that means if the condition is true, also this if is getting executed. If the condition is false, also it is getting executed. Okay. So if I write this count inside the body of if, only when your n value becomes, only when this condition becomes true, the count gets incremented. But for the false case, it will not. So only I'm writing this count outside the if. Okay, so now let's see how many times this count variable gets incremented. Okay, so for let us suppose n value is less than or equals to 0. So this analysis we have to do in two cases. The first case is when your n value is less than or equals to 0. The other case is the n value is greater than 0. Okay, so when n is less than or equals to 0, so then what will happen? Your if condition will become true. Your count gets incremented by 1 and the body of if gets executed. So in the body of if we have one more count statement. So this will get executed for one more time, a total of 2 times. So this is the value of the step count when your n value is less than or equals to 0. So let us see the step count when your n value is greater than 0. Okay. So if your n value is greater than 0, or in that case, your if gets evaluated, but it becomes false. So it won't enter into the body of the loop. But if gets evaluated, so this count gets incremented by 1 and it is coming to the else part. So in the else part, here I have one more count. Okay. So for the return, let us write it as 1. But here, if you see, I have the recursive calling of the rsum method again. But I don't know how many step counts will be taken by this rsum of a comma n minus 1. So I will write this part as t rsum of a comma n minus 1. Okay. So altogether, how many did I get? How many program steps did I get? It is 2 plus T are sum of a comma n minus 1. So now I have obtained the recurrence relation. What is the recurrence relation? So we can write it as T R sum of a comma n is nothing but 2 plus T R sum of a comma n minus 1. So if you solve this recurrence relation for the value of T R sum of a comma n minus 1, we get the actual programming steps needed in case of n greater than 0. Okay, so that we will be solving shortly after completing the tabulation method as well. Okay, so with this, the count variable method, how to introduce the count steps using the count variable method, we have finished. But we have to solve for the recurrence relation in order to get the total step count. So now let's see the tabulation method also. Okay. So in the tabulation method, what are the entries of the table? So the first one is the statement. Then you have S by E. Then frequency and followed by total steps. Right. So the first one. So this is part of the syntax. So this is not counted as a program step. Next is the opening brace. This is also not counted as a program step. Next, we have the if part. And here, if you observe, we need to solve this in two cases. Since it is an if else, you need to solve for n less than or equals to 0 case separately and n greater than 0 case separately. Okay. So similarly, you will get n less than or equals to 0 and n greater than 0 also. Just let me draw a separation now. So now let us take the value of S by E in case of, oh, okay. So if n is less than or equals to 0, what will be the value of S by E? How many times is it going to get executed? A total of 1 time. Steps per execution. And what will be the frequency in case of n less than or equals to 0? Totally, it is going to get executed for 1 time. And coming to the return part. S by E is 1 and also frequency is also 1. In total, it is getting executed only for 1 time. So now coming to the else part. Okay. So in the else part, so this is just part of the syntax. So that is once again you are coming to the case of n greater than 0. So there once again your if condition is getting evaluated. So S by E is anyhow 1. The frequency in this case is also 1, but the return will not get executed. Okay. And here we have one more return. So what will be S by E? So the return statement gets executed 1, but here I have the expansion of this recursive equation. I doesn't know how many times will it get executed for one execution. So in the earlier video, we have clearly seen how to elaborate this recursive equation, right? So there, since I doesn't know the program steps, let me write it as 1 plus x. Okay. So here in one single execution, steps per execution, one execution itself, this entire sum is going to get expanded, right? So it is recursively calling and it will back substitute. So only I'm taking the program steps as x. If you have not watched the earlier video, I will provide you the link in the iCard. Please do check that so that you will get a clear idea of this. Next. So frequency. This is not the case of n less than or equals to 0. So nothing here. So here it is. How many times will it get executed? a total of 1 time. So the return is only for 1 after back substituting. So the return is only for 1 time. So now let us take the total steps. First, for the case of n less than or equals to 0, 1 and 1 max is 1, 1 and 1 max is 1, and here nothing. Okay. You can also write it as 0. I'm keeping the dash here. And here max of, okay, so here 1 plus x, and here it is not at all getting executed in this case. So it is 0. So I will just write it as 0 only. Next, coming to the case of n greater than 0. Okay. So S by E is 1. Frequency is also 1. So the total steps are 1. S by E is 1 and frequency is nothing. So this you can also treat it as 0. Okay, so it is not at all getting executed. It will get executed for 0 times. So I will write it as 0 only. Else is part of the syntax. Okay, so now 1 and 1 plus x. Max is 1 plus x. We'll write it as 1 plus x. So now let's take the total. Next is a closing brace. It is part of the syntax. This is not a program statement. So now let us calculate the total, both in case of n less than or equals to 0 and n greater than 0. So when it is less than or equals to 0, 1 plus 1, a total of 2. When n is greater than 0, it is 2 plus x. Here once again we take x as t r sum of, because I doesn't know how many program steps we take for t r sum of a comma n minus 1. So now once again a recurrence relation is formed if you observe. So that is t r sum of a comma n is equals to 2 whenever your n value is less than or equals to 0, or it is 2 plus t r sum of a comma n minus 1 whenever your n value is greater than 0. So this is the same recurrence relation that we have obtained in case of the count variable method also. Okay. So now let us see how to solve for this recurrence relation in order to get the total number of program steps. Let us solve the recurrence relation. So what was the recurrence relation that we have obtained? What is the recurrence relation? From the recursive equation, whatever total steps that we have obtained, that we are calling as the recurrence relation. So it is T r sum of a comma n is nothing but 2 plus T r sum of a comma n minus 1, right? This is what we have obtained. So now I doesn't know the value of this T r sum of a comma n minus 1. Let me call this as 1. Okay. So now let me solve for this T r sum of a comma n minus 1. One moment, I'll change my color. So let's do that. I just want to find out the value of T r sum of a comma n minus 1. How will I get this case? Take equation 1. In place of n, you just substitute n minus 1. So wherever you find n, you just replace it with n minus 1. So the equation becomes T r sum of a. Here I have n. I replace it with n minus 1 is equals to 2 plus. Here I have T r sum of a comma n minus 1. Already I have a minus 1. Now my n value is n minus 1. So it is n minus 1 minus 1, which will become n minus 2. So that is 2 plus T r sum of n minus 2. So this is the value that I obtained for T r sum of a comma n minus 1. So let me substitute it here. Already I have a 2 Now I obtain this value. So the value is 2 plus P R sum of A comma n minus 1. So like this, I have to keep on substituting until I will be able to generalize this equation using mathematical induction. On seeing this, can you generalize? No. I need one more step. Let us do some more steps of substitution. So again, let me find out what is the value of P R sum of A comma n minus 2. So that will, once again, the base equation is equation 1 itself. So in that equation, I keep on substituting the value of n. So in place of n, I am substituting n minus 2. N minus 2 minus 1. So which I obtain as 2 plus P R sum of A comma n minus 3. So let me back substitute this. This 2 plus 2 remains the same. I'm not doing anything with this part. But now I got the value of this, which is 2 plus P R sum of A comma n minus 3. Okay. So now if you observe this, are you able to generalize anyway? So here, if I rewrite this as 2 into 1, what I have here? N minus 1. So in the same way, here two 2's I have, here I have n minus 2. So I can I rewrite it as 2 into 2 plus PR sum of A comma n minus 2? Yes. So similarly, here I have three 2's. 2 into 3 plus PR sum of A comma n minus 3. So now, in a similar line, using mathematical induction, what can we say? So when I substitute this for n steps, so that means in place of 3, I will be getting n plus PR sum of A comma n minus n I will be getting, right? So I have substituted this for n number of steps. So finally, what is the value that I obtained? Here I obtained 2n plus PR sum of n minus n is 0. Okay. So from the earlier recurrence relation, whenever your n value is less than or equals to 0, what is the value of PR sum of A comma n? PR sum of A comma n. The value of this is 2. So let us use that value here. 2n plus 2. So finally, I obtain the total number of steps. So finally, what I can conclude? So the total number of steps for this recursive method is PR sum of A comma n is 2 whenever my n value is less than or equals to 0. Otherwise, it is 2n plus 2 when my n value is greater than 0. So solving this recurrence relation is also important for your exam. Let it be your mid exam or let it be your final exam. So this is also equally important. Okay. So from this lecture, you are getting benefited in two ways. One is you are coming to know how to solve the recurrence relation. And the other way is how to solve the time complexity given a recursive algorithm using the tabulation method as well as the count variable method. Okay. So in both the cases, we obtained the same recurrence relation. So these are the total number of steps for both the cases. Hope you enjoyed the video. If you have any queries, do post in the comment section. I'll try to answer all your queries. Thank you. See you in the next video.